Florida, 2005, and Hurricane Wilma was the most intense hurricane ever recorded in the Atlantic. It was the fourth Category 5 hurricane in what was a record-breaking season. During this century, average global temperatures are predicted to rise by around 3 degrees Celsius, and a pattern of increasing severity of storms is already being recorded. In 1997, the Space Shuttle Columbia recorded this image of Hurricane Enrique off the Pacific coast of Mexico. Such severe tropical storms can only form above warm oceans. In August 2005, Hurricane Katrina hit the American state of Louisiana. It was the third strongest hurricane ever to hit the United States, causing severe damage across Alabama, Mississippi, and Louisiana, with the worst in the city of New Orleans. Although evacuation warnings had been issued, most of the city's poorer residents lacked the means to leave New Orleans. No one expected the federal flood protection system to fail so completely. The Superdome sports arena became a focus for those needing shelter, but major parts of the roof failed due to high winds. It sheltered 30,000 of New Orleans' poorest citizens, while the government bungled evacuation efforts. Fleets of buses were sent to wait uselessly at the edge of the floodwaters, with helicopters reserved for bringing in camera crews and police. The people here were the weak, the frail, and those who had stayed behind to protect them. At first, the refugees at the Superdome were calm and ordered, but as days passed and the government of the world's richest country dithered, an atmosphere of desperation set in.
Get us out of here! We want to get out of here!
6 deaths were confirmed at the arena, 4 from natural causes, 1 from a drug overdose, and 1 as a result of suicide, but in reality they were all victims of Hurricane Katrina. The city's network of levees had broken in more than 50 places, and 80% of New Orleans was flooded, with the water taking weeks to clear. More than 1,800 people lost their lives to the hurricane and the accompanying floods. Many of the levees did not break, they were just not high enough to keep the storm surge out. Criticism of the government's inadequate response was widespread. The National Weather Service had provided accurate forecasts well before the region was hit, but state and federal authorities did not react. It took months to re-establish essential services like water and electricity, and to rebuild bridges and repair roads. Months after the hurricane, residents were trickling back to their homes to survey the damage. An investigation led to the resignation of the Federal Emergency Management Agency director, but considering the high loss of life and damage to infrastructure, it was a small price to pay. The role the Superdome had played during the disaster gave it special significance. Repair work started, but it would not reopen for more than a year. Reconstruction of the levees was a priority, but there was debate about the adequacy of the repair project. Engineers differed over whether the rebuilt system was any better than the network it replaced. In September 2006, the Superdome reopened after extensive refurbishment. For many in New Orleans, it was a symbolic return to normality, more than 1 year after Hurricane Katrina. In November 2007, Cyclone Shear crossed the low-lying coast of Bangladesh. It tore through more than a dozen coastal districts, killing around 3,500 people, as well as leaving tens of thousands missing. More than 3 million people were affected, losing their homes, livelihoods, and families. With sustained winds of 260 kilometers per hour, Cyclone Shear was classified as a Category 5 storm. Hurricane Katrina was a Category 2 storm. During spring in China, sandstorms are not uncommon, but in April 2006, Beijing was hit by its most severe dust storm in 5 years. A According to the official China Meteorological Association, about 330,000 tons of sand fell on Beijing during just one night. The grit from such a sandstorm only adds to Beijing's already severe traffic pollution, with cars forced to slow due to poor visibility. The sand that sweeps Beijing during these storms comes from China's Inner Mongolian Autonomous Region. From this particular storm, the fallout went beyond national borders, with sand and dust from China blowing as far as Korea and Japan. Spring storms choke Beijing each year, but the situation during 2007 was unusually bad because of poor rains across northern China. The cleanup was extensive, but Beijing is equipped to sweep dust from roofs and gutters. For the city's drivers, it's different. Cars pick up dust so quickly that drivers are reluctant to clean them till after the windy season. Beijing's government has tried dramatic means to bring relief to the parched and dusty north of the country. In the past, batteries of artillery around the outskirts of Beijing fired shells containing silver iodide particles into the clouds. It has been difficult to assess how effective this cloud seeding really is. For years, the sand in Inner Mongolia has been advancing, and local villagers and domestic animals have been driven from their homes. Whole villages have been swallowed by sand, and residents have to shovel sand from their doorways just to clear the way out of their homes. China's government is implementing long-term plans to fight desertification and ease the dust storms, but the lack of rain and changing weather patterns are not so easily solved. Ocean racing yachts are designed to cope with all weather conditions, but for the Volvo Round the World yachts, competing in Australia's Sydney to Hobart race in 2001, very light winds at the start were a problem. The race is known for the unpredictable storm cells that can suddenly break in Bass Strait, but the early stages of the 2001 race looked like it would be a tame affair. 8 Volvo-class 18-metre boats were competing in the 630 nautical mile Sydney to Hobart as part of the third leg of their race around the world. As the boats headed south, the winds freshened. Pre-race favourite and defending champion Nicorette, skippered by Ludde Ingval, was in 6th place and was making up ground slowly as the fleet of 70 yachts neared Bass Strait. The weather continued to change, and as the lead boats entered Bass Strait, they were battling strong southwesterly winds of 25 to 30 knots. Conditions were now favouring the big boats, and Nicorette was in the lead. Sailors were taking the race seriously. Just 3 years previously, 6 yachtsmen died and 5 boats sank as fierce storms and 10-metre seas battered the fleet. Soon, the crew of Nicorette knew they had a problem. The crew immediately dropped all sail and worked to lash the mainsail down before the tornado struck. Several crew members were struck by large hailstones, and Ingval tried to avoid the storm. Most of the crew were ordered below deck. Ingval and 2 others stayed above to steer Nicorette, but he feared for his life as he felt himself being sucked into the air. With only 4 nautical miles separating the first 4 boats at the scheduled early morning radio position report, other boats were suffering too. They struggled to keep out of the path of the waterspout, But such intense, low-pressure storms follow an unpredictable line, and it was impossible to be in control. Nicorette could not avoid the tornado and capsized, with the mainsail being ripped from its lashings. The crew were able to right the craft and spent 6 hours replacing the damaged main. Tornadoes are rapidly spinning columns of air that extend from a cumulonimbus cloud to the ground. They occur around the world, though their most violent manifestations tend to be in the central regions of North America. Tornadoes develop from a supercell thunderstorm. These storms have a strong rotational pattern a few kilometres above the ground. When heavy rain drags air into a strong downdraft, it starts to rotate like the air in the supercell. As this rotating downdraft gets closer to the ground, it spins faster. A large tornado can rip trees from the ground and buildings from their foundations. The old saying, "Everybody talks about the weather, but nobody does anything about it," could soon be proven wrong. For a long time, people have been seeding clouds to try and make it rain. But an effective way of minimising the intensity of damaging storms has never been tried. If someone could do something, it could save lives and property. Now, Dynomat, a Florida-based company, says it has successfully tested a polymer substance capable of removing storm clouds from the sky. Just a small amount of this white powder can absorb a large amount of water. Tests using a B-57 aircraft, flying out of Palm Beach, Florida, scattered more than 4,000 kilograms of the product into a storm cloud mass about 60 kilometres off the coast. During that day's test, team members removed a building thunderstorm completely from the atmosphere, a feat documented by Doppler radar. The active polymer ingredient is capable of absorbing an amount of water 2,500 times its own weight. Though it looks impressive, weather experts are doubtful that it would be possible to deliver the amount of chemical needed to the right place at the right time. Still, the company is attempting to gain investors. Even if it could be proved just to weaken hurricanes, it could be of immense benefit to populations living in areas prone to the devastation of tropical storms. Scientists in the United States are concerned by the high number of powerful storms there have been in the very recent past. In 2005, when Hurricane Dennis hit the Caribbean and Florida, it was the fourth named storm for the season, a season which went on to deliver Hurricane Katrina. It was the most severe Atlantic hurricane season on record. Of the storms that crossed the coast, Dennis, Emily, Katrina, Rita and Wilma were responsible for most of the destruction. Scientists believe warmer oceans are causing the increase in intensity in storm frequency and severity. According to a comprehensive study, hurricanes will become even more intense because of global warming. A climate modelling study at the Geophysical Fluid Dynamics Laboratory used one of the world's most powerful computers to simulate 1,300 virtual storms. It found that within 80 years, the average hurricane strength will increase by half a category in the 5-step scale of destructive power. The combination of warm ocean and favourable prevailing winds is delivering more powerful storms more often, starting earlier in the season. Average wind speed could jump by 25 kilometres an hour, rainfall by 50 millimetres, and storm surge by around a metre. The next stage of the study will explore how a changing climate might affect the future frequency of storms. The researchers are keen to incorporate new data into their climate models, and work being jointly carried out by America's National Oceanic and Atmospheric Administration and NASA will help answer questions about how storms are triggered. 2 studies, one into the birth of hurricanes and another into the effects of global warming, were based in Costa Rica to spend a month at the peak of the hurricane season monitoring oceanic thunderstorms. The high-altitude aircraft is fitted with sensors to collect temperature, humidity, precipitation and wind information on either side of a storm front. The data they gather could help improve weather forecasting and lead to better hurricane warning systems. The information allows the team to study cyclogenesis, the creation of the ideal breeding conditions for tropical storms and hurricanes. The project is also gathering data on sea surface temperatures in the tropical Atlantic and Pacific. The researchers say they have developed an understanding of how mature hurricanes behave. With this study, they are concentrating on trying to understand what the early stages of a tropical storm or cyclone look like. At this stage, the computer models are yielding many false positives, predicting that a hurricane will form when in practice it does not. Costa Rica is an ideal site to carry out this hurricane research. It's bordered to the west by the Pacific and to the east by the Caribbean Sea, and has a 7 to 8 month long rainy season. Around 15 tropical storms and hurricanes originate near the western coast each year. They have an impact on the eastern Pacific. Many areas concerning the chemical and physical processes that occur in the upper troposphere and its boundary with the stratosphere are still not well understood by scientists. The mission coordinates observations taken from satellites, high-flying NASA research aircraft, balloons and ground-based radar to study gases and ice crystals that flow from the top of storm systems. Known as the TC4 mission, it will help NASA understand the interrelationship between global climate change and ozone depletion. Scientists want to document the full life cycle of the clouds in as much detail as technology will currently allow. Special equipment in the aircraft can analyze the chemical content and composition of the clouds. The storm systems pump air more than 12,000 metres above the Earth's surface, where it can influence the composition of the stratosphere, home of our planet's protective ozone layer. 3 different monitoring aircraft were coordinated to fly in stacked formation to deliver a 3-dimensional image of the chemical makeup of the weather formations. Balloons and ground-based monitors were used to supplement the picture. The mission will provide a baseline study for future comparison. To get a global picture of the Earth's changing wind patterns, the European Space Agency is preparing a wind monitoring satellite called Aeolus. Central to the satellite's mission is an instrument which fires laser pulses towards the atmosphere and measures the Doppler shift of the collected return signal. This will give an unprecedented view of the growth of large tropical storms. By recording and monitoring the weather in different parts of the world, the wind monitoring satellite will help climatologists build more complex models of the planetary environment. Another new tool in atmospheric study will soon be in service. Known as Helios, it flies at 3 times the altitude of a commercial jetliner, and its 14 electric motors are powered by 65,000 silicon crystal solar cells. Helios is remotely controlled and can fly for months at a time above all weather. It will provide a low-cost platform for atmospheric monitoring equipment. Other applications include monitoring pollution, monitoring of the oceans and natural resources, as well as an observation platform for disaster management or hurricane tracking. Because it is solar-powered, Helios will leave no exhaust traces in the stratosphere, which will make it perfect for high-altitude atmospheric analysis. Finally, the unique conditions generated by a strong winter storm in just the right place brought big wave riders Mike Parsons, Brad Gerlach and Adam Cohen to the Mexican island of Todos Santos. Gale force winds produced waves with faces well over 17 metres in height. Parsons said they were the biggest waves he'd seen in the area since he began surfing there 20 years ago. It's not easy being in the right place at the right time to take advantage of this freak surf. Storm surfing on waves this big makes the riders eligible for the Billabong XXL Big Wave Awards, a worldwide competition for those riding the biggest waves. These waves are so big, the surfers need a tow from a jet ski to catch them. Rain and weather buoys further north, along the California coast, recorded offshore swells in excess of 8 metres, some of the highest readings in a decade.